Hello, welcome back to Cracking the Cryptic, and another intriguing puzzle sent in to us by a viewer who I think hasn't seen the community post showing our preferred submission guidelines and sent us 6 or 7 puzzles. But anyway, I've been recommended this one. It's by Math Pesto. It's called Knuckle Sandwich, which I assume is just a pun on sandwich Sudoku, but anyway, we'll have a look at that in a minute. I do want to mention, of course, our Sudoku hunts on Patreon. One of them is free. That is the Murder Mystery, and that has been available for a few days and will be closing on the 31st of July. So you have a long time still to enter that. Do give those puzzles a try. Part of the joy there is working out how each puzzle relates to the next one and how you can solve each one in turn, and then there's a big finish. In Jovial's Sudoku Extravaganza, which was our July reward puzzle, and that is for paid patrons, whereas the Cracking the Case of the Roman Tragedy is free. In Jovial's there are 20 linked Sudokus. Really clever work, and do give that a go if you can. Now, let's have a look at this Knuckle Sandwich. Actually, I should mention our apps, as always. They're also all available. Great value. They are listed in the links in the description field where you can find how to play this in our software. And as I say, this is by Math Pesto. It's called Knuckle Sandwich. It's relatively simple, arrow and sandwich Sudoku. So the numbers 1 to 9, obviously in each row, column and box, normal rules. And along an arrow, the digits sum to the number in the circle. And the clues outside the grid, we haven't done a sandwich Sudoku for a while, but they show the sum of the digits between the 1 and the 9 in that column. So somewhere in, or row, somewhere in this column are a 1 and a 9, and in between them, the digits that appear add up to 12. So that's it, that's all we get. Do give it a try. And I'm going to try now. Let's get cracking. Okay, we've got, it's a very symmetrical puzzle. We've got 4 3-cell arrows. So their cages have to be, given that the arrows are in straight lines, their circles, have to be 6, 7, 8, or 9. Now 9 will obviously have an effect on the sandwiches, and they are all in these rows and columns. How do we use them? Something we often do in sandwich puzzles is mark in green, traditionally for some reason, the cells that cannot contain a 9 or a 1. And obviously arrow cells can't contain a 9. Well, those ones can't. This one could, but only because it's a 1-cell arrow. That's sort of... Let's have a look at this 5 row. It's sort of interesting. Where can 9 be in this 5 row? Okay, yeah, look. 9 can't be there or there. And it can't be here because the sandwich would have to be at least 6 if the 9 was there. The same's true here. So 9 can't be in those cells. 9 can't be in arrow cells. So one of these definitely is a 9 in this row. It certainly could be here with this 5 sum. That could be a 5 and that could be the 1. Or they could add up to 5, and in those cases you'd have a 5 or a 6 in this circle. 9 there would definitely need that to be a 5, that to be a 1, and that to be a 3. Okay, so in this case 1 would be there, and in the other case 1 would be in one of those 2 cells. So 1 is always in the middle somewhere, and these cells I can colour green as not 9 or 1. Not that that helps for those columns, but 1, yeah, those could add up to 5. That could be a 5, or that could be a 5. Maybe we can take this approach into the columns, although 5 was a nice low number. What about up here? See, it doesn't work so well. You could have 9 there, because then you could go 6, 2, 1, 3, and that would be a valid 8 sum and a valid arrow. Oh, okay. Don't really know what we're meant to do then. Oh, yeah. In these rows, these arrows have to add up to at least 15. So both in the rows and the columns, the circles always have to add up to at least 15. Is that useful? No, I'm quite wrong. I'm quite wrong because those arrows do not pertain to these 2 circles. They pertain to those 2 circles. Right, so those 2 circles have to add up to 15 at least. So do those, so do those, and so do those. That means these inner circles are also all 9, 8, 7, or 6. Now that means it can't be 5 here. And that means this can't be a 1, because that was arising if we had a 2, 3 pair there, which can no longer be the case. So it's either 5, 1 or 5, 1. So in fact, there's a 5 in one of those 2 cells, which is a bit kludgy pencil marking, but never mind, it is true. Now, if that's a 9, I just don't know up here. Sorry, this is taking some thought. How do we figure anything out? Okay, the maximum those 2 can add up to is 18. So these can never add up to more than 18. I think they always have to have a 1 and a 2 on these arrows. So the 1 and the 2 can never be on the outsides of columns and rows 2 and 8. I think that must be right. Yeah, 1 and 2. So 1 and 2 are always on the insides here. So I don't know quite how to pencil mark this, but the 1s are interesting from the sandwich clue point of view. So 1 is always somewhere in here. Can 9 be on the edge here? No, it's difficult. I don't think this could be a 9, for instance. Because the most this could be is 6. And then where's the 1 going to come? If it comes there, that would have to be a 4, but this would only add up to 5, which is impossible, and that's going to be worse. You can't have that plus that in the sandwich, because that's going to be at least 12. So that cannot be a 9. Yeah, you don't get enough by just adding those 2, given the possible values for that. I think that's right, because those 2 can't just add up to 12. Yes, okay, so that cannot be a 9 or a 1. Now that must be true this end as well, surely. Oh no, it's not, because the arrow points a different way. Hang on. If that was 8, 3, 1, 4, that does work. Okay, let's try here. 9, 6, 2, 1. Can that be a 9? It would be great to rule it out somehow. So it would be adding whatever that total is, 6, 7, 8, or 9, plus that, to get this as the 1. If that's a 9, 1 is here. Don't think it can be here, because these would then have to add up to, yeah, there'd be 1, 2, 3, 5. That doesn't work. Right. So if that's a 9, 1 is here. If that's a 9, and those add up to 9, that's impossible. This can't be a 9, because these would add up to 9. The sandwich would require another 2 and then a 1. That's not happening, so that's not a 9. Can this be a 9? I think I just worked out it could. 8, 3, 1, or 7, 4, 1. But in either case, 1 was going to be here, but hang on, it could be 6, 2, 3, 1. But that's not a 1. Because when we're looking from the top, we said that 1 was... Where did we say it was? 9 could be... No, 9 was here. Actually, let's mark that green, because that's not the 1 or 9. In fact, this is the 9 now in this row. That's there. That's the important deduction. And that means that 1 is here. No, it doesn't. It means that's a 5 and that's a 1. That's what it means. 5, 1, 3. And we're away. We've done something. Let's remove the 5 from there. Right. So 9 is in one of those 2 cells. And if it's here, now I've just worked out 1 could be in either place. If it's here, 1 is there. So that's not a 1. 1 is definitely in one of those 3 cells. And 9's either at the bottom or top, so those can go green. How about that? Now, this is a 9, so that's not a 9. Can that be a 9? I don't think this can be a 9. Oh, 8, 1. Maybe it could. Yeah, that's not. I don't think there's a problem with that. Otherwise, this can be a 9, 8 in those 2 cells, and that is 1, or 9 there. 8, 1 again, or 6, 2, 1. Okay. Not easy. Right, these though, those can't be 1s, because we know where the 9 is. Right. These 2 add up to 6, 7, 8, or 9. These can't all add up to 12, or this whole bunch would have to add up to 13. That's fine. So 1 is not there. 1 is definitely in one of these 2 cells. So everything else in the column is green. This is a very odd puzzle. Now, 2, am I really saying, yeah, 2 does have to be in these 2 cells. That was because these 2 have to add up to no more than 18. And that's not a 1 now. So this is either 2, 4, or 2, 6, or 2, 7. Ugh, that's not a 7. Those 2 are green as well. Right. Those add up to 6, 7, 8, or 9. So 1 can never be here, because that wouldn't be the 12. So 1 is here. That can be green too. Oh, can that be a 2? Yes, it still can. So these add up to, well, that's not a 9. Sorry, it's in the same box as a 9. These add up to 6, 7, or 8. So that is 6, 5, or 4. It can't be 6, because that's not a 9. Right, so it's 5 or 4 there. This cannot be 6 anymore. This is 2 or 3. That is not a 2, obviously. this pair adds up to 6, 7 or 8. Two, 6, 3, 5, 3, 4, 2, 5. Okay. I don't think it can be 6 because they would have to be 2, 4, and then these would be 3 and 5 and add to 9. So okay, that's not 6. So we've got 7 or 8 there, 7 or 8 here. Now, can that be 9 if that's a 1? Yes. What next? What next? This is 8, 7 or 6, so the 1 must be on the arrow, so that can't be a 1. Now what does that mean? Does that mean we know 9 here would require the 1 to be there because they add up to 6, 7, 8 or 9. The balance could be there. Then 1 would be here. 9 here. Oh yeah, it was possible for this to be 6 and this to be a 2, 3 pair and that to be 1. Although that would then make this have to be a 4, 5 pair and this a 9. Which would put 9 here. Yes, 9, 6, 2, 3, 1, 4, 5. You'd get 8 and 7 up here. It does look possible. Simon often says, when you do find one way to make something possible, it's quite likely to be right. But we cannot rely on that. So, still going to have to work on row 2 a bit more. There must be some way of narrowing this down. And immediately I start looking at other things instead. But now, if this is a 9, they will add up to 8, and that will be a 1. That must be right. So if it's not a 9, 9, 8, 1, is the other possibility. It's very tricky. How do we work this out? Maybe I need to focus on these. Together they add up to not 14, because that wouldn't leave enough here, 15 or 16, which is 1, 2, 3, 4, and either 5 or 6. I don't know how to deal with that. Okay, let's think again. Can this be where 9 is? It would have to go 9, 8, 1. This would then be 7 or 6 and would need a 1 on it. So that's nonsense. Okay, so 9 is not there. So 9 is in one of these two cells. And that's not 9. And that tells us, doesn't it, that this can't be 3, 2, 1 on a 6 arrow. So I think that means this can't be 9. Oh no, 8, 3, 1, 4 or 7. It means this can't be 1. Yeah. It does mean this can't be 1 because the only way that could be a 1 was with those two adding up to 5 and that being a 6 and that being a 9. That is not 1. This is where the 1 is in the column. So we've got a bit more green there. Now it still doesn't make, I don't know whether that's a 9 and this makes up the balance of 6, 7 or 8 towards 11, or whether this is a 9 and that's a 3 or a 4 making up the balance of that. But I do know where the 1 is, and that feels like a tiny bit of progress. Now if that's a 9, this is getting difficult surely. 8, 3, 1, 4. That becomes 7. But it could be 9, 7. No, it couldn't. If that's a 9, 6, 2, 1, 3 won't work. If that's a 9, this has to be an 8, and that has to be a 1. Then this is a 7. 8, 1. Oh, is this possible? 9, 8, 1, 7 there. Those two are either 3, 4 or 2, 5. This couldn't be a 6. Oh, I don't know. I don't know how to resolve this at all. It seems unlikely that this goes 9, 8, 1. It makes this a 7. Then you get 2, 4 here. These have to be a 3 and a 5. So you'd have an 8 here. These would have become 8. Oh, 8 here would mean this would be a 7. Oh, this doesn't work. Right, 8 there would mean that would be a 7. Since those have to add up to at least 15, that has to then be another 8 to make those two add up to 15. So that cannot be 8. Wow. So that can't be 9, because the only way it was, yeah, 6, 2, 1, 3 has a 3 clash. Wow, okay, that is bonkers, but that is 9. That's taken some working out. Those two must add up to 8, and that's a 1 to make this work. And we can get rid of all the 1 pencil marks at least. These two are either 2, 6 or 3, 5. We can do all the greens in that column. Have we got all the 9s and 1s? Ah, we have now, so that's green as well. These two add up to 6, 7 or 8, so that is 3, 4 or 5. I'm not sure there was much point keeping these 2 pencil marks in. I suppose they're useful there. What's this? 2, 3 or 4 there. Am I? Yeah, that's 11. Sorry, that's 3 or 4 or 5 because of the 11 sum. This 8 has been done effectively. That 12. No, it hasn't been done until I know whether that's 7 or 8. Now those can't both be 7, or these won't add up to enough. So one of them at least is 8, and that means this can't be an 8. Also means these two cells can't be an 8, but that's less useful. But this is now 6, 7 or 9. If it's 6, that's a 2, 4 pair. If it's 7, still 2 possibilities. Can't. No, it's not a 2, 5 pair because that wouldn't leave a fill here. It's 2, 4, 3, 4, 4, 5, or 2, 7. It can't be 3, 6. So it's from 2, it's either 2, 4 if it's 6, 2, 5 if it's 7, 4, 5 if it's 9, or 2, 7 if it's 9. Wow, that's a lot of possibilities. 8 now, 5's been done, the 12 is still waiting on that, the 11 is still waiting on that. Oh, good grief. Okay, but these have to add up to at least 15, and that's only 7 or 8. This can't be a 6. And again, one of these must be an 8, because 2 7s wouldn't leave that being enough, so this can't be an 8. So there's no 6 there. So 6 is in one end or the other here. If 6 was there, that's a 9, then that's a 4. So that can only be a 4 or a 6. But if 6 is there, it's a lot less clear cut. That could still be 2, 4 or 2, 7. Right. Have I got anything else? It's interesting that this pair is 2, 4 or 2, 7. They're quite different things. This is a very hard puzzle, isn't it? Ah, this 14. Good grief, I've got a 1 in it. Sorry, I hadn't noticed that until now. Right. Those two could be 6 and 8 with a 9 here. Although, how could 9 be here? 9 couldn't be here because 1, actually we can place the 1 in the middle box. Good grief, there it is. So 9 can't be there. In fact, 9 is either here or here in row 5. And this can't be, if 9 is there, it's 3, 6 because of that 4 or 5. If 9 is here, again it can't be 4, 5. Could be 6, 3, or it could be 2, 7. Okay, let's take out the pencil marks. But 9 is in one of those two positions and is made up, the 9 sum is made up of 2 cells. So let's green those just because I'm keeping the colouring going. Now, it's a 3 cell sum. It can't be 4 because the 3 is gone, so we can put a 9 in here. And those are green. And these 3 add up to 14 without a 3. 4, 5, 6 would be 15. They must have a 2 in. And they're either 2, 5, 7 or 2, 4, 8. Doesn't affect anything else, does it? Oh, maybe it affects this possible pair. This can't be 4, 5, and it can't be 3, 6 now, because that can't be 3 or 6. So it's either 2, 7. Oh no, this is if the 9 is this side. Then it's 2, 7. Then it is 2, 7. If the 9 is this side, this is a 2, 7 pair. If otherwise, it's 9, 3, 6. Wow, so either that's a 3, 6 or this is a 2, 7 pair. And one is right and one is wrong. I am going to corner mark that in the hope I can remember what my corner marks mean there. Either that's a 3, 6 pair or that's a 2, 7 pair. Now, if that's a 3, 6 pair, this adds up to 8. So then that's an 8. This would also have to be an 8 because that would go 3, 1, 4. So if this 3, 6 pair is right, we get an 8 there and an 8 there. I don't know why there's a problem with that. That might be all right. What if this is a 2, 7 pair? This becomes an 8. So then we get 8s here. So either that's a 3, 6 pair and we get 8s there, or this is a 2, 7 pair and we get 8s here. What else would that do? It would make this a 4 or a 5. Eights here, 2, 7. I don't know. It looks like it could work, although that would make this a 9. That would reduce this to 7 or 6. This is really weird. Crumbs, I don't know what to do here. That's 8 there. Remember, one of those must be an 8, so those can't be 8s. One of these must be an 8. So those can't be 8s. That's interesting. That's true, isn't it? One of those must be an 8. And therefore these can't be 8s. So 8 in column 2 is in one of these two cells. Definitely. And was that working over here as well? Those can't be 8s, so those are never 8s. Yes, so 8 is definitely up here in one of those two. I'm not sure that really helps, but it's quite interesting. Okay, so if this is a 7, that has to be an 8. Now what does that do? And it also makes this a 4 for the 11 sum, and this a 3 therefore for that 8 sum. That 4 makes this a 5, so this becomes an 8 as well. 5, 1, 2 with an 8 there. Has a lot of effects. So if this is a 7, we get an 8 here and an 8 here. We know that this one is a 3, 1, 4, that one's a 5, 1, 2. That pushes a 2 to here and to here. Wow, this is complicated. It doesn't have a huge effect on anything else. Am I missing something? Am I missing something? Oh, I am missing something. Right, if that's a 7, which makes this an 8, and this a 4 for the 11 sum, which makes this a 5. Now that forms part of the 12 sum. So this becomes a 7. So if that's a 7, these are all 7s. Oh. And this can't be a 7 or have a 7 in its sum. So it must be, must have a 4 in the sum then. That's quite an interesting effect though. If this is a 7, then these are both 7s, then that's not a 2-7 pair. So then we've got 9, 3, 6, 1. That becomes a 9. Oh, does this break? Feels like it's going to break. It's really interesting though. If that's a 7, for the 11 sum, this is a 4, so that's a 5. For the 12 sum, this is a 7. So these would all be 7s. And this has become an 8 sum, so the 7 in row 2 has gone there. Ah, and then there's no 7 you can put in column 8. That's it. My goodness. Right, I'm just going to take you through this again in case you either doubt me or want to follow it again. So if this was a 7, it's either 7 or 8. If it was a 7, those two add up to 7 in the 11 sum. That becomes a 4. That makes this a 5. And in the 12 sum, those two add up to 7. And don't include a 7, by the way. So 7 is now here. But this becoming a 7 and these two becoming a 7 means the only place for a 7 in row 2 is here. And then there's nowhere for a 7 in column 8. So that's not a 7. Wow, that is crazy. Okay, that's an 8. These two add up to 8, and this is a 3. And this now can't be a 3. 2 wouldn't make the right sum, so that's a 4. This is an 8. Oh my God, this is so tricky. So that's not a 4, which doesn't resolve what this is yet. Oh, this is an 8 made up without 3, 1, and 4. So that is 2 and 6. We've got 5 and 7 at the ends of the column. That's not an 8. Oh, that's quite interesting, because if that's 2, 7 with a 9 here, and we still don't know which way round this goes. If that's 2, 7 because of a 9 here, that becomes 8. And now this sum can't have an 8 in it because of the 8 there. So that would be a 2, 5, 7 sum. That's if this is 2, 7, 9. That's become a 2, 5, 7 sum. This is 8. So this is a naked single 6, which makes this a 9. I'm losing my head here. Okay, that's quite interesting. If that's a, I've just seen this. If that's a 9, that's 2, 7, and this has to be 6. Otherwise, it's a 6. So the 6 in this box is in one of those two positions. But anyway, what I was looking at, if that's a 2, 7, that's a 9, and that's hitting this cell. That's hitting that cell interestingly, surely. That's 2, 5, 7. This is a 6. This is an 8. 9. This has become 7 or 6, which must use the 2. So that would have to be 3, 5. I don't know. Why not? Why not? That seems to work. Oh, Lord. Right, how about if this is 9, 3, 6, 1, and that's a 2. So then we have 6s there and there. Then that can't be a 6, which is not very conclusive. It's amazing that I still don't know where the 9 goes in this row. And I mean, the trouble is, even if it goes there, that can still be a 6. Even if it goes there, that could still be a 2-7 pair. Okay, let's think about this cell then. What if that was... if that was 7, then these would both have to be 8s. These would be 1, 2, 3, 4, 6. This would be a 5-7 pair. Obviously the 5 would be here if that was a 7. Oh, that's brilliant. That is brilliant. This can't be a 7 because of this cell. If that was a 7, these two would be 8s. Then you would have... Oh no, maybe it doesn't work. 2, 1, 4, 3, 6, and I was thinking that would have to be a 2, but actually that could be a 3. 2, 1, 3, 4, 6. You'd have 5 here and 7 here. In fact, that would be a 3, and that doesn't stop that being a 2. Ah, nearly, nearly. This takes such looking ahead. 8, by the way, is in one of those 3 cells, which I'm sure does absolutely nothing for me. These two being the same. I mean, 7's interesting because it puts a 4 in one of those cells. It also puts a 6 in one of those 2 cells. But why not? It could be, couldn't it? The answer has got to come in these cells somewhere, or is there some very obvious problem with either 9 and 6 there, or a 2-7 pair there? Don't know. I'm going to keep trying, because it's really interesting me now. Now, if that is a 6, then we have 2, 4, 3, 5. That's got to be a 6. This is a 7-8 pair. What does that do? 6, 6. Oh, that's interesting. If this is a 6, it makes that a 2, which makes this a 3, which definitely makes this an 8. So if that's a 6, this is an 8. If that's a 7, this is an 8. Is there some way to prove it's an 8 if this is a 9? I doubt it, but let's have a look. 9 there would do what? Just doesn't have the same sorts of effect at all. Actually, does it though? It would put a 9 here, which I hadn't seen before. Oh, in fact, is there always a 9? No, not always. Those can't be. Might as well keep the colouring going because I'd forgotten to do it for a while. All of these can't be 1 or 9 because they can see 1s and 9s, given that there's a 9 in one of those 2 cells. So if that's a 9, we get a 9 there and a 9 there. Yeah, then this is a 3, 6, 1 thing. Then you get 2 there, 6 here. think it could work. Whereas either 6 or 7 makes that an 8. Hang on, 9 there would give us 9 here and 9 here. Which gives us a 6 here, a 2 here, a 6 here, and stops this being a 6 because I've posited it as a 9. That's fine. Six there. And 6 here, which gives us 4 here. I don't know, this is craziness now. This really is a tough puzzle. 46 minutes in. I mean, I've got some digits, but I mean, I'm still trying to concentrate on this. This is interesting. Maybe let's focus on this being 2, 7, which makes this an 8, and this a 9. So now that is 6 or 7. And we know that both of those make an 8 here. We've worked that out before. So 2, 7 there gives us 8s in all these places. And what does that do? It makes this a 2, 5, 7 sum. We know that. And that makes this a 6. Which makes this a 9. Which makes this a 6. Which makes this a 6. Wow, okay, that'll do. That's something. This is something. 2, 7 there makes those 8s. Right, I'm postulating the 9 here. If the 9's here, we get 2, 7 there, which makes these 8s. 9 there makes this a 6 or a 7, which always make this an 8. Now, what was the proof of that? That was because a 6 there put a 2. Why did a... Let me just recover the proof of why... Oh, 7 there obviously makes that an 8. 6 here made that an 8 because what? Because that's 2, 4, that's 3, 5. 6 would have to be there. And this was for some reason an 8, 7 pair. But somehow that proved this was an 8. I'm going to rely on the fact that I worked out earlier that it was. Can't remember exactly how I did it, but I did do it. Anyway, I'm relying on that. So if that's a 9, we get 2, 7 there, we get 8 here, we get 8 here obviously as well. This has become 6 or 7 because of the 9 here, so that becomes an 8. And now what was this proving? This was proving... I've just worked this out. Come on, try and remember what you proved. I'm trying to prove this is definitely a 6 either way around. So 9 there, 2, 7, 8. Oh yes, this becomes 2, 5, 7 because there's no room for an 8 in it. 9, 3 with an 8 there. This becomes a 6. That makes this a 9. And that... Does it definitely make this a 6? 9 there would put a 9 here, therefore. You'd have 1, 2, 7, 9, 3, 8. Oh, I thought this proved that that was going to be a 6. Now, how did I come up with this a moment ago? 9 there gives 2, 7, 8's here, 8 there, 6 here. That's interesting. 9 here. Oh, that makes this a 6. 9 being there makes that a 6. Which makes this a 4. That's a... Oh, I'm sure I had just proved that this was a 6 either way. 2, 7, 9. Come on, Mark. Come on, you can get to this. 8 in those positions. 8 there, because that's not a 9 anymore. Yes. 8, of course. Once this is an 8, those add up to 8. That's a 4. And that's a 3. 2, 7, 1, 4, 3, 8, 9. Could this be a 5? Oh, this is really important. Okay, if that's a 9, this is 2, 7, that's 8. Those add up to 8. That is a 4. So those are 2, 5. No, those are 3, 5. No, I don't know. They could be 2, 6. That's absolute nonsense. Right. 9 there makes 2, 7 here, makes an 8 here. I'm sure this works. That's going to give us a 6 here by the naked single on the 2, 5, 7. That gives us a 9 here. 2, 7 pair there, 6 here. Oh, I could see it. For a moment I could glimpse it, but maybe it was worth testing it because maybe it doesn't quite work. Now the alternative is 9, 3, 6, 1. We get 2, 6. That's not a 6 now. That's 7 or 9. Oh, I can't quite get it back. That's painful when something's elusively there and disappears. Sorry, folks. Let me just think again. 2, 7 there gives us a 9 here. Now that ends up giving us a 6 here, which gives us a 9 here. So 9 will then end up there. So 9 is either here or it ends up here. So 9 is in one of those two positions. And therefore one of these two. I don't think that proves anything for me at all. If that's a 6, does that prove this is a 6? Maybe that was what I was assuming and it wasn't that solid a presumption. That's quite possible. That would make this a 4, and we would have a 4 here anyway. So we'd end up with a 4 in one of those two cells. It's all about whether this is 2, 7, isn't it? I just have a feeling it's not. Well, okay. We know some of the consequences if that is 9 there with 2, 7 there. Let's look at 9, 3, 6, 1 here. That 6 makes this a 9. That makes this a 2, 7, which makes that 6, and this a 4. Well, even if this was 2, 7, and we had a 9 there, that made this an 8, and that made this a 6. And either way, you get a 6 there or a 6 there, and this is a 9. Okay, that'll do. So this is a 2, 7 pair, and we can do 6 and 4. Now, we still don't know whether that adds up to 7 or 8, but we've got a 6 there now. Is that any use? And a 4 here. Or that 2, 7 pair? 6, we've still got 1, that's not a 9. 9's in one of those 2 cells, which is not very helpful either. But at least we got this as a 9. Looking at positions for 9's now, not really working out. Working out which way round they go. So if this is 2, 7, let's have a look at column 5 now. We get an 8 here. This is now 2, 5, 7. That's a 6. So then we would have 8 and 4 in the ends. But maybe this 6 is the important thing. 1, 2, 5, 7. 2, 7, 8, 5. Nine, 3, 6, 1. Maybe we should look at if that's 2, 4, 8. Then that becomes a 7. Then that has to be 8. Oh, and this has become a 5 because of the 12 clue. And that's a 2, that's a 2, that's a 2. So if it's 2, 4, 8, that's a 2. If it's 2, 5, 7, that's an... No, we don't know that. 7, 1, 9, 3. I don't know. If it's 2, 4, 8, it goes 4, 8, 2. That's what I just worked out. If it's 2, 4, 8, how did I just work that out? Because it's an 8 here, so that's a 7, because that one can't be an 8. 7. So if it's 2, 4, 8, that's a 7, which makes this a 5, and that a 2, and that can't be 2. In fact, that becomes 2, and the 2 ends up here. So if it's 2, 4, 8, that becomes a 2. Now, if it's 2, 5, 7, that's 6 or 8. I can't see it. I can't see it. There's something going on. Maybe it's if this is 7 or 8. If it's a 7, that ends up being a 2. If it's an 8, though, and that's a 4, well, that can never be a 4, at least. Okay, how about that? Because it's either a 2 or that's a 4, one way or the other. Oh, come on. The trouble is, I don't even have a 7-8 pair there, because that could be 7 with 5-2 there and 7 there. This is so rock hard. 6 there would give you a 2-4 pair there, 3-5. That would give you a 6 here and an 8-7 pair here. I don't know, this is so tricky to see through. I mean, I'm just left wondering. I thought for a moment I'd proved this had to be a 6. Trouble is, maybe that wouldn't even help if I could prove that, although I think then I'd get 2 there and 6 there, and that couldn't be a 6. That feels like it would be something. It's this cell. I'm sure it's this cell. If it's a 6, 2, 4, 3, 5, 6, well, that makes this a 2. That puts that as a 6, which means this can't be 3, 6, which means this is 2, 7, which means this is a 9. So if this is a 6, this becomes the 2, 7, 9. That's quite interesting. Now, if it's a 7, we get 8s here and here. That's a 4, that's a 3. What does that do? If it's a 7, we get 8s here in all these positions. That becomes a 6, doesn't it? Eight somewhere there, 8 somewhere there, 8 somewhere there, and oops, not there, 8 somewhere there. And I can't see what breaks about that. I don't want to resort to a complete bifurcation. I really don't. Even if this looking ahead feels like bifurcation to some of you, I don't think there's any other way to do the puzzle. So I'm not at all embarrassed about trying to look ahead a number of moves. And I do want to do this, what I consider logically. So if that's a 6, then that has to be a 9. That's quite interesting. If that's a 7 and this is 2, 5, that doesn't work at all. Am I only just seeing now that that cannot be a 7, because that would be 2, 5, and this couldn't be either 2, 6 or 3, 5? My goodness, that's pathetic. That is true though. That is not a 7 possibility. So now it's down to 6 or 9. And if it's a 6, that becomes a 9. So the only place in the column for a 9 is in one of those two. Well, that's quite interesting. Right, let's work more on if it's a 6, and this is 2, 4, and that's 3, 5. Then we get a 6 here, and that becomes a 2. Oh, that becomes a 2 anyway. So if that's a 6, that's a 6. And 6 in the central box is in one of those two positions. But that becomes a 6, doesn't it? Oh no, that's not necessarily the case, just because that's a 6. 4, 5, 2, 6, 1, 9. Oh, I see. If this is a 6, that becomes a 2, that becomes a 3, and this must be an 8. Whereas if this is a 9, we get either 2, 7 here, and that's an 8 again, or we get 4, 5 here, and that's 2, 6. 2, 6. And that's 3 or 7, and that is where 8 is now in one of those two cells, but also in one of those, so it must be here. 9, 4, 5, 2, 6. 8 is now in one of those two cells, but also one of those, so it must be there. In fact, this conclusion is solid anyway. 8 in this row is in one of those two cells, but earlier I've proved that in the column it's one of those two cells, so it must be there. That is an 8. Oh, Lord. I'm not sure that gets me anything done, but it's a relief to know. Now, this either adds up to 8, in which case we go 4, 1, 3, so that would then be 2, 6, or it adds up to 7, in which case we go 5, 1, 2, so it would be 4, 3. So either 3, 4, or 2, 6 in either order. Now, okay, let's think about this again. Now we know that that's an 8. 6 there would give a 2, 4, 3, 5. So we'd have 6 and... oh, that would be a 7 because of that. And this would be a 6. So again, 6 is in one of these two positions. No, hang on. If this is a 6, you get 2, 4 here, 3, 5 here. There's nowhere for 6 in the row. Okay, that's better. This is a 9. But I still don't know whether that makes this 2, 7 or 5, 4. My goodness. 2, 7 would make that 3, 5. Then you'd have 6 here and 4 here. Or 4, 5, which would make this 2, 6. Then there'd be a 3 and 7 to place. That's not a 9. This is the point. Now we know where the 9 is in the middle row. There it is. And that's a 6. 2, 6. Wow, brain absolutely scrambled. I mean, this is a knuckle sandwich, which is a slang for a punch in the face. And it literally feels like it has delivered that. Absolutely mad. Let's just get rid of the shading now. We've used it all. Oh, it looks very plain grid suddenly. Anyway, 6, we got that as a 2, so this is not a 2. 8, come on, please, please give me some way into a finish now, puzzle. I still don't know what this is. Right, if that was 2, 7, this would have to be 8s, because they couldn't be 7s. Now the alternative is that that's 4, 5. Oh, this can't be a 6 anymore, so that can't be a 2. If that's 4, 5, we go 6, 2, and then we've got this 3, 7 pair on the outside. In fact, that can't be a 5, and that can't be a 4 because of this 5. Now, what about across the middle? 9, 3, 6, 1. Got 2, 4, 5, 7 and 8 to place. Let's get rid of those 2, 7 pencil marks. They were about 9 being over this side. 3 and 6 still to place. Not sure. These are from 4, 5 and 7. I mean, this is frustrating that we're not done now, having done all of the clue bits apart from that, I suppose. Now there's definitely... No, what are the possibilities here? This could be a 4, and if those are 7s, that's a 5. Then this is a 2. That would be interesting, because that would always make this a 2. So if that's a 5, that's a 2, because this 14 sum needs a 2. But if that's 8, and that's 4, then what? Ah, then this is a 2, 5, 7 sum. So that can never be 8. Three, 4, 5, 1, 2, or a 2, 6 pair, 4, 1, 3. I mean, I still do not know what is going on. So if that was a 7, we'd get a 3, 4 pair, a 5 there, and a 2 there. Ah. So if that was a 7 and we get a 5 here, this does become a 2. If it's an 8 and we have 2, 6 there, 4, 3. No, I don't see what's going on. Oh, I really thought it would all become clear once I got this sandwich done in the middle row. Oh, what about this now? 1, 9, 3, 4. It can't be 2. That's hardly reduced impossibility at all. Sevens here would make this a 5, 4 pair, which would make that 2, 6. Oh, okay, if that's 2, 6, this shouldn't even have a 2 pencil mark, but if that's 2, 6, that 2 makes this a 7, which makes this a 5, 4. Then we have 1 and 3 to place in the ends of the column. I don't know, this has done my head in totally. I'm feeling so fried, I just don't know what to do. Oh, that can't be a 4, and this can't be a 5. Let's just tidy up some pencil marks for want of anything better. 7 is in one end or another there, and it's obviously also there, which is an X-wing, ruling 7s out of all sorts of other places, which I'm sure makes no difference at all, because nobody's been trying to put it into those places. Ooh. Well, that nearly puts it into this sum. Can that be a 7? Maybe that's the question. If that's a 7, which puts 8s here, and a 4 here, and a 3 there, it also makes that 2 and that 7, 4, 5 pair there. This becomes a 5, that becomes a 7. So we've now got 7s in these positions. and there. This is postulating a 7 here. Oh, come on. What else does it do? Oh yes, that makes a 7 here, because that's where it would have to be in column 8. But then you'd be left with other random positions. It's just not clear. Is there a clearer way through the... Oh, look, 9, 9. I can place a 9. I'm sure that does no good. I've got an X-wing on 9s there. Did that 7 X-wing really help? Okay, if that wasn't a 5, the 5 in column 8 is there. Then you've got 5 7s on all those positions. In fact, the 5 wouldn't be there or there. These would be 7s. That would give you a 7 here. It's 5s I was marking, isn't it? I just don't know how this helps. Sevens there. Then we have 7s on the corners or on the ends of column 2 and 8. Then we have 1 7 in one of those positions. Ah, and the 7 in, okay, interesting. The 7, if those were 7s, the 7 in row 5 would be here. So that wouldn't be 7. So that would be, so that wouldn't be, so that wouldn't be. And you'd get a 7 here. That would be 7, and that would be 7. So that is a possible positioning of the 7s. If these are 7s, they have to end up like that. So what if they're 8s? Then that's a 4 for the 12 sum, and this is a 3. What does that mean? That being a 4. Ah, then this has to be a 7, because you have 7 and 5 out the ends. If that lot adds up to 16, yes, okay, so the 5 would have to be there. This would be a 7. So if they're 8s instead, you get a 7 here. That gives you a 7 here. So this is the opposite way round, effectively. Where else? Is there anywhere else that gives you a definite 7? Ah, if they're 8s, right, if they're 7s, that we got the green 7s, and that ends up being a 7. If they're 8s, that's not an 8. And if that's a 7, that's not an 8 because of the 14 sum. So that's never an 8. So now we know that the 14 sum is 752. Is that worth anything? We've still got 4, 6 and 8 to place in the column. I don't know, it feels like it ought to be worth something. This now cannot have an 8 in it. It's 2, 5, 7. So if that's a 2, that's a 2. It doesn't mean anything. Okay, let's go on with thinking about these being 8s and that giving us a 7 here and a 7 here. Oh, if they're 8s, the only place now for an 8 in row 5 is here. So if they're 7s, that's a 7. If they're 8s, that's an 8. So that is 7 or 8 there. So 4 is definitely in one of those two places. No, it's not. It could be there. That's nonsense. Okay, don't worry about that. So if they're 8s, that's an 8. And that's an 8. So if they're 8s, this becomes a 6, doesn't it? Okay, if they're 8s, that's a 4. And that's an 8. So then we have a 2, 5, 7 triple here. That's interesting, isn't it? So these other cells are always from 3, 4, 6 and 8 in box 5. Either that's a 2, 5, 7 triple with an 8 there, or that's a 7 and that's a 2, 5, 7 triple there. So the 2, 5, 7 triple is either there or there. Ah, what does it mean? Come on, there must be a way through this. There's got to be a way through this. If that's a 7, then yeah, we know I've highlighted the green 7s if those are 7s. So if those are 8s, and that's an 8. This becomes a 6, doesn't it? 7, 9, 8, 3. Yes, it does. So that could no longer be a 6, and that can no longer be a 2. So then 2 is here. This doesn't work. Is that right? No, this can't be right. If that's an 8, this is a 6, And that means this can no longer be a 2. Oh, but it could be a 6. It could be 2, 6, 4, 1, 3. No, that didn't yield anything. 6 here. Oh my goodness gracious. I don't want to give up. It seems so pathetic. So 1, that could be a 1 at one end of this row. Then we get a 1 there, and 1 there. Alternatively, we have a 1 here, which gives a 1 here, and a 1 here, and a 1 here. So they're in rotationally symmetrical positions wherever they are, these 1s. So they're not in the corners. Don't think that helps. One more sandwich clue would be useful, wouldn't it? Oh dear. So if this was a 2, that would be a 2. That would be a 5, so of course this would be a 7. So then that would be a 5. Green would be a 7. So if that's a 2, obviously all the greens are 7s. In which case that's a 5-4 pair. So then if that's a 2, that becomes a 2. Because those greens aren't 7s. And that would have to be a 2, but it's a 7. Oh my goodness, he's cracked it. So if that's a 2, which makes this a 5, and these add up to 7. So all the greens become 7s. But if that's a 2, with all the greens being 7s, that must be a 5-4 pair. The 2 in row 2 is there, and now that would have to be the 2 in row 8, but it cannot be because it has to be a 7. So that is not a 2, that is a 3. We get a 4 here. Please let this finish this puzzle, although I have a feeling it might not know. We now know that there's no 3 or 4 here. Have I definitely ruled out this having a 5 in? I think I have. So that is now 2, 6. Have I definitely ruled out that this is 2, that this could be a 5? Let's just undo that. I think I have earlier. Okay, I'm going to rely on it because I think I did rule it out successfully earlier. Now, these are 8s, so now I can ignore these greens, which would have been 7s. That is not right. So those are not 8s. Now there's a 2, 5, 7 triple here. We know where 8 goes in row 5. We've got a 5, 7 pair on the ends here. Let us get rid of the green markings, which are indeed irrelevant. Now we do get 8s in those remaining places and not here. We get an 8 up here. Is that 3 not doing any more work, or that 4? So we get a 4 up there in one of those 2 spots. Oh, come on. 2, 5, 7. Oh, that can't be 8. That is 6 now. That is a kind of naked single that we've been waiting for. That makes this a 2. 6 there. That can't be 6. So one of those is a 6. And that's 3 or 7. Come on, keep going, don't stop here. That is 2, 3 or 7. Yes, 5 gets placed here, of course. 5 and 7 are resolved. So 5 and 7 are resolved in column 2. That 7 stops that being a 7. Still don't know whether this 9 is a 5, 4. That is 4, 5 or 7, 2. But the only place for 2 in this row is now here. I'm missing something there. Yes, I am. So 5 is not in those positions. It's up here. That's not a 2. That triple is fixed. That is a 4, 6 pair. We get a 3 there. These don't have a 7 in. Okay, come on and breathe and carry on. And let's try and finish this puzzle. What an extraordinary puzzle it's been. 1, 3 and 6 to place around the corners here. That can't be a 3. Look, this can't be a 7 or a 2. That's 4 and 5. So this is now 2 and 6. That's a 7 and this is a 3. That's 1 or 6. That's 1 or 4. 5 in this box is there. That's 1 or 4 as well. That makes this an 8 and this is 6. 2 and 1 can go in. This is a 2, 4, 7 triple in row 3. But we can place 9 and 3 in the top row. We can place 8 and 4 down there. The 7 and 2 are resolved. That has fixed 4 and 7. That has fixed 4 and 1. I'm getting very excited now. 3 there. 1 and 2. That's not a 3. That's a 3. 7, 5, 9. Surely I can do this 1 and 6. Yes. The 5-2 pair is resolved. That's a 7. That's a 2, 4, 7, 4, 6. Finally, limping over the finish line. What a blow to the face that knuckle sandwich has been. Well done, Math Pesto. I mean, it's very clever, but my goodness, it takes some looking ahead to figure that one out. Honestly, if people have been polishing that off, hats off to them. That is tough as old boots. What a puzzle. Sorry about the deductions that took so long. I'm very pleased to have got to the end, I have to say. Very pleased. That really was extremely difficult, but great fun. Fascinating. Anyway, that's about the longest Sudoku video I've ever done. Certainly on one puzzle, and delighted to have got through it. Hope to see you again sometime on the channel if you can bear it. Bye for now.